6.3 Piecewise functions. For chapter 6, we are starting with 6.3 because of time. After this lesson, you should be able to write, including from word problems, piecewise functions, graph piecewise functions, and evaluate piecewise functions. After this lesson, you should be able to write piecewise function, graph piecewise functions, and evaluate piecewise functions. What is a piecewise function? A piecewise function is a function that is in pieces. It's in different parts. So it's a function that is a combination of one or more functions. Again, it's a function that's in little pieces. The rule is different for different pieces or parts of the domain. So here's an example. At AMC theaters, movie tickets cost $11 for children ages 2 to 12, $14 for adults ages 13 and up, and $13 for seniors ages 60 and up. So with this example, we're going to write a piecewise function, graph a piecewise function, and evaluate the piecewise function. By the way, I googled AMC theater price, and this is what I got. $11, $14, $13, rounded to the nearest dollar. Okay, so part A says write a piecewise function for the cost of the ticket for age X. So I'm going to put f of x for function notation. That means I'm going to have some kind of cost depending on the age, right? Depending on your age, you're going to pay a different price for movie tickets. So it's $11, right? It's going to be $11 if you are between 2 and 12. So if you're 2 and older, you're going to pay $12, but it's going to be less than 13, right? Because even if you're a day shy of 13 years old, of turning 13, you still get to pay the children's price. So that is that first part, and it says it's $14 for adults ages 13 and up, but up until before you turn 60, because once you hit 60, you get to pay the senior discount price. So it's $14 if you're 13 or older or less than 60. And then it's $13 if you are 60 or older. So here is my piecewise function. Look at, I have 3 different functions going on, right? I have a different rule, like it's $11, $14, or $13, depending on the domain, right? Between 2 and 13, this is a rule that applies. 13 to 60, $14, and so forth. So you need to be able to write a piecewise function given a scenario. Okay, so part B, it's going to ask you to graph the function here. So let's go ahead and graph this. So I know in my x, right, in my x, it's going to be age. And in my f of x, it's going to be the ticket price, right, in terms of dollars. And for my age, I am going from like 2 to 60. So I'm going to go ahead and just label by every 10. Okay, so I just went ahead and labeled it going by 10. And in the y direction, or f of x direction, my cost is like $11, $13, $14. So I'll just go ahead and count up every 2. Okay, I've labeled the y-axis for ticket price going up every 2 units. So let's see. It says that it's $11 for children 2 to 12. So it's 11, y equals 11 if you're between 2 and 13. So 2 would be about right here, because it's like 5, 1, 2, 3, 4, 2 to 13. So 11, 12, 13, 14, 15, 1, 2, 3. So 2 to 13, the cost is $11. So 11 will be right here. So I am going here. It's inclusive right here. And then at 13, it's going to be an open circle because it's not inclusive of that 13, right? So when you're 2 and older, reaching up to 13, like right before 13, 2 to 12, you are paying $11. And then you are paying $14 if you are between 13 and 60. So between 13 and 60, right? Between 13 and 60, you are paying $14. So right here, once you hit 13, you no longer pay $11, you're paying $14 up until you are age 60, exclusive of that, right? Okay, so it's just a straight line going through. And once you are 60 or older, you get to pay $13. So the discount price of $13 applies when you turn 60. So right here, and then going to the right. So there is my final graph. So let's say if you were 13, right, you would pay $14, right? If you were 10 years old, you would pay $11. If you're 30, you pay $14. If you're 59 years old, you pay $14, but once you hit 60, you would get the senior discount and pay $13. Okay, last part, part C says evaluate f of x for x equals 13, x equals 16, and x equals 62. So remember, evaluate means to find the value, right? So find the value. What is f of x? Remember, f of x is your age, right? With the cost. What is the cost if you are at age 13? If your age is 16, if your age is 62. Okay, so let's take a look at the first one. Find f of x for x equals 13. That means if your input is 13, what would your output be? If you are 13 years old, how much will you have to pay? Okay, so for these problems, for piecewise functions, always look at the right side. See how there's like two parts? Here's the rule, and then here's like the domain. What you do is you go to the domain and then use the rule that applies. So 13, right, where does 13 go? Where do you see 13, right? 13 is right here, right? Because 13 is a number between 13 and 60, it would be the second one. So the rule is $14, right? Your output is 14. So 14 is your final answer. When you're 13 years old, you're going to pay $14. If your input is 13, the rule that applies is the second one, so 14 is your output. Let's take a look at x equals 16. So where does 16 apply? Well, 16 is a number between 13 and 60, so the rule would still be 14. So f of 16, right, when the input is 16, the output for f of x, or for that f function, is 16. Okay, let's take a look at x equals 62. What happens if your input is 62? If your input is 62 from this domain, where would that number belong? Right, it's the last one, right? 62 is a number greater than or equal to 60. Therefore, only that rule applies. So 13 is the rule that you use. So f of 62, when your input is 62, right, your output is 13. If you're 62 years old, you get the senior discount. You're going to pay $13. Okay, so going back to the graph real quick here, do you see how these are just like horizontal lines? So yeah, the graphs that we're going to see, they're going to be not just lines. When you have a piecewise function where they're just made up of lines here, though, they are called step functions. So this is a step function because they look like little steps. What we will have is going to be a combination of the various parent functions. Okay, before we go on, let's recap the different graphs of common parent functions. So y equals x would just be a line, right, going through 0, 0, up 1 over 1. So it would look something like the following. Okay, y equals x squared, right, 0, 0, 1 squared is 1, 2 squared is 4, right, it's a parabola. It's a parabola, right, so you remember that's the shape. Y equals x cubed, 0, 0, 1, 1, 2 cube would give you 8, right, so it looks something like the following on this side. -1 quantity cube is -1, right, it's going to look like the following. So think of like John Travolta dancing, that type of a thing. All right, y equals absolute value of x, right, that's the V shape. It's basically your line, but all the negative parts, right, the negative y values become positive. So it's going to be this V shape. That's y equals absolute value of x. Y equals square root of x. Let's think about that. The smallest number that can go inside of the square root is going to be 0, because anytime you put a negative, you get I, right? Square root of -1 is I. So square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. and you end up with this type of a graph, right? Square root of 100 is 10, and so forth. Let me try graphing that again. It should look something like this. It's growing steadily. All right, y equals 1 over x. What happens when you plug in 0? You get undefined, you get a vertical asymptote. When I plug in 1, I get out 1. When I plug in 2, I get 1/2. When I plug in 1/2, I get out 1 over 1/2, which is 2. So you end up with this type of a graph. If you remember, this is from last semester, chapter 5, rational functions. So let's see what happens when you plug in -1, right? When you plug in negative, you got 1, you get -1, and you end up with this here. It's a hyperbola. So again, you want to remember the basic shape. You have a vertical asymptote down x equals 0, and a horizontal asymptote at y equals 0. Okay, let's take a look at cube root of x. Cube root of 0 is 0, cube root of 1 is 1, and then cube root of like 8 would give you 2, right? Cube root of 8 would give you 2, so you end up something like this. Cube root of -1 is -1, so this is the type of graph that you're going to get. So you want to think a snake or a walk like an Egyptian in terms of the move that we're going to learn in class. How about y equals 2 to the x, right? That's a exponential function, so you have an asymptote at y equals 0. 2 to the 0 is 1, 2 to the 1 is 2, right? You're going to have an exponential growth function like so. And y equals log base 2 of x, that one has a vertical asymptote. What is log base 2 of 1, right? 2 to the what equals 1, that's going to be 0. So when x equals 1, y equals 0. What about log base 2 of 2? When x equals 2, what does y equal 2 to the 1 is 2, right? So when x equals 2, y equals 1, and you end up with this type of a graph, right? Remember, these are going to be reflections of each other over the diagonal y equals x. So you want to remember these basic shapes. Just as a recap, y equals 2, right? That's a horizontal line. Horizontal line going this way, y equals 2. And x equals 2 is a vertical line going through x equals 2. So for graphing piecewise functions, and for other parts of chapter 6, knowing these basic shapes of the parent functions will really, really help you. So you are expected to know them and know what the shape looks like right away. So if I tell you, what does y equals square root of x look like? You want to know that this is a basic shape. Okay. So in class, I will teach you like a cheer and maybe a dance to help you remember these graphs.